Welcome back, chemistry fans. Today, we are going to talk about Unit 9, Topic 2. This is attractive forces. So this is the most important aspect of this unit. Let's jump right into it. So another word for these attractive forces are intermolecular forces. So we've got to learn what in the world those are. To do that, we need to then start talking about let's break down the root of the word. Let's get into the etymology. So you are aware that there are roads that connect states, and those would be called interstates. 95 goes right past us. It heads up to DC. It goes into Maryland. In fact, it goes all the way from Maine all the way down to Florida. Interstate 95, very long, and connects many states. So a road in between states is called an interstate. If we have little highways in between us, it is called an intrastate highway. So intra is inside, inter is in between. Okay, so if we have that root word, then it might make a little more sense for us to understand that intermolecular forces are in between two different molecules. Those are the attractive forces that we will be focusing on. Intramolecular forces is what we've been talking about all before this moment. Those are how electrons are shared between two different atoms. Well, there's no electrons being shared in an intermolecular. It's just because there is a dipole moment, because the hydrogen doesn't have very many electrons around it. It has a overall dipole of a positive, and this oxygen would have a negative. They are attracted like magnets. Positive and negative attract one another. That is an intermolecular force. Specifically, this was a hydrogen bond. So we will talk about that one in just a second. Intermolecular forces, for the very definition, for the basic definition, is an electromagnetic attraction. So in other words, a magnet, it could also be a repulsion if they're the same charge, but if they're opposite charges, they're going to be attracted to one another. And it happens between molecules. Why does it occur? We will talk about that when it has to do with polarity, the size and the shape, the stories that we have already talked about previously. So intermolecular forces can be one of 4 different ways. We will probably not talk about the ion dipole, however. That's not as common. What we're going to talk about is the fact that that hydrogen bonds are the strongest of the intermolecular forces. Now, if we want to talk about ions, ions are by and far the strongest bonds, but that is something that we have talked about whenever we were making ionic compounds. We have the bonds between ions and the positive and negative, the cation, the anion. That strong attractive force is what makes an ion dipole. But these are more attractive forces that exist between molecules. So we're going to focus on these top half up here. We're going to focus on the hydrogen bond being the strongest, and then the dipole-dipole. And the dipole-dipole is an attractive force between two molecules that has mostly to do with shape. This one has mostly to do with size. And then finally, the dispersion forces have to do with the movement of electrons. So we'll get into those individually right now. Let's start with the weakest of these forces, dispersion forces. If we have electrons equally distributed throughout the atoms, they will not attract one another. There will not be one side that has more electrons than the other. But as time moves on, there will be an incident, a very brief incident in time where all of the electrons shift to one side. Just by the chance, there will be more electrons on one side than there are on another. Anywhere we have more electrons, that's going to create a negative dipole. Anywhere where we have an absence of electrons, that creates a positive. Well, if we have that same scenario, one side would have more electrons than the other. That is going to cause an attractive force. So reading this definition over here, it is the weakest intermolecular force. It is based on attraction between temporary movement of electrons. One atom has a lack of electrons on one side. One atom has a surplus of electrons on one side. That creates a negative and a positive. Those attract together like magnets. But because it's temporary, it's not very strong. Dipole-dipole happens to be based primarily on the shape of the molecules. So it can be some to do with size, but primarily the way we will see it displayed is that there is going to be a shape polarity. So noticing down here on the second half, we have this molecule, because of its unequal sharing of electrons, there are more electrons on the oxygen than there are on the hydrogens. The hydrogens do not carry electrons because they're so small, so it takes more time, it spends more time on this oxygen, meaning that there is a higher negative charge than there is on the other side. Well, just because of a dispersion force, there may be all of the electrons over on one side of this molecule. So the positive and the negative, they will attract. And we usually show that with a dotted line in between. If we drew a solid line, that would indicate that there is a bond. Well, now, similarly, what you would see up top, it's based on mostly, again, size, in that the fact that the electrons spend more of their time around the larger atom, and the dispersion forces have all of the electrons on the argon over on one side. This creates a positive and a negative. There is an attractive force between those molecules that, again, we represent with dashes. Reading the definition, this is the middle of the intermolecular forces, not as strong as the final one, but it is stronger than the dispersion force. It's between electrons of one atom and the lack of electrons in the other because of a permanent polarity. So based on size and based on shape primarily, there's going to be a permanent polarity that exists in these molecules. One side is always going to hold the electrons longer than the other side, and that means that it will have attractive forces for some other molecule that has a similar temporary or permanent movement of the electrons. All right, moving on. The third is the hydrogen bonds. Hydrogen bonds only occur between three atoms: nitrogen, oxygen, and fluorine. It is the exact same as a dipole-dipole because the hydrogen is so small that there is a strong attractive forces, remembering that these are three of the strongest electronegative electrons. They pull the electrons to them the strongest, the nitrogen, the oxygen, and fluorine, creating these temporary dipoles, the negative and the positive, meaning that they will be represented with this dashed line as the attractive forces in them. Okay, well, what does the attractive forces do? Well, it causes the molecule to stick to one another. And so just like honey is very sticky. Why is it sticky? You're saying because it's honey. No, because of attractive forces, because the molecules stick together. They do not want to pour. Water has very low viscosity. They do not hold together as well. If you have high viscosity, that means that the particles are sticking together stronger. They resist being poured. That's what is happening with honey. Water does not have as strong of a attractive force, and therefore it has a lower viscosity. Another property that can, this is the same one, but we can overcome viscosity if we heat it up. What happens when you heat up a particle? You get the particles further apart, so the attractive forces are not as strong, and therefore, the hotter you get, the more you can overcome attractive forces, the lower the viscosity goes. All right, now, one of the other details that comes about with this is the idea that if you have strong intermolecular forces, they will have surface tension. And what that means is, if you've ever noticed, raindrops are round. And you're saying, well, of course they're round, they're liquid. Well, liquids do not typically want to form little balls. Water is very unique in that it has a very strong intermolecular forces compared to other properties. So it resists deformation. This is called surface tension, and it pulls on itself to form little spheres. That's why rain droplets are individual, why they don't like to group together into big puddles. Whenever you have them on a wall, that is why teardrops are round until they hit a ground and puddle, as you see there. So surface tension is attractive forces between molecules that cause them to reduce their size. So what is happening is these particles are pulling themselves closer together, and that means that the surface is actually shorter than it is down below. They are pulling on the other particles, moving it closer, and that means that they resist being poured, kind of like the viscosity. And what this does is it creates these little balls. Another interesting side effect of attractive forces is boiling point. It's the exact same story. Because they have high attractive forces, the particles stick together, and the closer they are together, they're more likely to stay a liquid. If they are further apart, because their attractive forces aren't strong, it is easier for you to turn them into a gas. That's the very definition of boiling. Boiling is whenever you convert a liquid into a gas. So if you have high attractive forces, you have high boiling points. It takes more energy to rip them apart. You have to overcome the attractive forces that are in between the molecules. Okay, so that is everything that I wish to share with you today about our attractive forces. Now you have a little bit more complete story about some of the interesting aspects that are around us today. Talk to you again soon. Thank you so much for staying with me. Bye-bye.